Hi everyone, welcome back to the channel. So today we are going to discuss different techniques that are used in rational agents under AI. So as in previous lectures, we have already discussed about rational agents. So these agents are basically designed to make some optimal decisions based on their goal set, based on their previous knowledge and the available resources, right? So here we have some key techniques that can enhance rational agents' decision making and their adaptability. So the first agent we have is search algorithms and path findings. As we have already discussed in data structures and algorithms, we have so many search algorithms like A star algorithm, we have depth first algorithm, we have breadth first algorithm. All these are search algorithms in computer science. So in AI, if we talk about A star algorithm, it is basically students a widely used search algorithm that combines cost and heuristic estimation to efficiently find the optimal path, and it can commonly applied in navigation and game AI. So it is basically used in navigation systems. All right. Now, if we talk about depth first search, these two are basically classical search strategies used for traversing state spaces. If we talk about only depth first search algorithm, it can be memory efficient. It can be memory efficient. And if we talk about breadth first search, it can ensure finding the shortest path in an unweighted graph. This is very important statement. All right. Breadth first search algorithm ensures finding the shortest path in an unweighted graph. All right. So all these are search algorithms and path findings. Another technique is heuristic based techniques. So students, under heuristic based techniques, we have two basic techniques. First is meta heuristic optimization, and another technique is heuristic search. So what about heuristic search? Algorithms like greedy search, best first search use heuristics to prioritize the paths that appear more promising, speeding up the decision process. There we use heuristic search algorithms. Okay. Next is our meta heuristic optimization. So in this technique, it includes some techniques like genetic algorithms, simulated annealing, and practical swarm optimization are used to find near optimal solution. Meta heuristic optimizations basically helps us to find near optimal solution in any complex environment. All right. Third technique that we can use in rational agents include reinforcement learning. So under reinforcement learning, we have some techniques like Q learning and SARSA. All right. So popular reinforcement learning algorithms where all the agents learn optimal policies. All the agents in rational agents under this learns some optimal policies by updating value function. This is very important. They can ask in examination how agents learn the optimal policies. So you should note that they learn optimal policies by updating value functions based on actions and the rewards. Based on their actions and rewards. All right. Another technique is your deep reinforcement learning. Deep RL. This is simply known as DRL. All right. It combines deep learning with reinforcement learning for complex environments. This is basically used for the complex environments with high dimensional state spaces such as games. If we want to create any environmental game, or robotic task, then we can use deep reinforcement learning technique. All right. So I hope students everything is clear till now. If you have any doubt, you can comment below, and if you want me to continue the series with such real life examples, you can definitely comment below. Next technique is Markov decision processes, that is MDPs, and partially observable MDPs, that is called POMDPs. All right. So under this, we have the first algorithm, that is Monte Carlo sampling. This is Monte Carlo sampling. It is basically used in complex probabilistic models to estimate the outcome. To estimate the outcomes and uncertainty, enabling rational decision making in uncertain environments. That's why we use Monte Carlo sampling. Another technique used under this is HMM. It stands for Hidden Markov Models. This model is useful in time series data and sequential decision making, and HMMs also enable agents to make predictions. It allows agents to make predictions. We are talking about rational agents here, right? Predictions and infer hidden states over time. Next point we have is probabilistic reasoning and Bayesian inferences. So first technique under this is your Bayesian networks. Here graphical models that represent dependencies among various variables, and also these networks allow agents to update the beliefs and make decisions based on probabilistic evidences. So this is the basic definition that is important. Another technique is hidden Markov model. All right, hidden Markov model that we have discussed earlier. Next is game theory. Game theory and multi-agent systems. So under game theory and multi-agent systems, we have a technique that is cooperative game theory, simply known as CGT, cooperative game theory. So some techniques like bargaining and coalition formation help agents coordinate and maximize joint benefits in collaborative settings. Another technique is minimax and alpha beta pruning. We have discussed earlier all these points in detail, right? So these two are essential for adversarial environment like board games, etc. And they can minimax optimizes an agent's actions, assuming an opponent is also rational. Okay, and if we talk about alpha beta pruning, it reduces the search spaces. So board games जितनी भी होती हैं वहां पर हम मिनीमैक्स एंड अल्फा बेटा प्रूनिंग को यूज करते हैं. Seventh technique we have is machine learning for predictive and adaptive decision making. So we use machine learning techniques in rational agents. Basically under this machine learning techniques, we have a first point, that is deep learning. These deep learning techniques are used in perceptual tasks such as images, speech recognition. Deep learning can also enhance agents' ability. It can enhance any rational agent's ability to interpret high dimensional data, informing rational decisions to all the agents, right? Next point is ethical and fair decision making constraints. So under this, we have two techniques. First is fairness aware algorithm, and another technique is rule based ethical constraints. So if we talk about fairness aware algorithm, if we talk about multiple agents or we talk about human centered AI, a fairness constraint ensure equitable outcomes across agents or users, especially in social context. If we talk about the resource allocation, then we use fairness aware algorithm. All right. And if we talk about rule based ethical constraints, so ethical frameworks such as restrict agent actions in sensitive scenario, avoiding harm, and adhering to user defined constraints, all these are taken under this particular category. All right. So this is all about some techniques that we are using these days under rational agents. I hope students everything is clear to you. All these 8 points are very important for your examination. If you have any doubt, you can definitely comment below. I will try to give you answers as soon as possible. And if you want me to continue this series or you want me to continue any other particular unit, then definitely you can comment. I will help you. So thank you so much and all the very best everyone.